Okay, so I'm hoping today's stuff should be pretty self-explanatory. We're moving into the polynomial section, and as you can see here, kind of got a breakdown of what we're doing. As an introduction, we're going to start with reviewing first and second degree polynomials. So first degree polynomials will be linear, second degree polynomials will be quadratic. So more or less what you did in grade 9 and then in grade 10 and into 11. Some key terminology, just things you're going to run into in this section, so you should sort of have them ahead of time. A function is basically any relation, so any equation where every x value can only give you one y value. Okay, so if we're looking at an example here, and I've got some sort of a curve, something like this, pretty simple stuff. As long as we go through, and this is called the vertical line test, as long as we go through the graph and only hit it at one spot. So again, every x value down here only has one y value up and down, then we have a function. Again, just a definition. Domain is all the x values that exist. Range is all the y values that exist. So sort of going back here, assuming this is a continuous curve of some sort, eventually every x value is going to be hit. As this continues out this way, it's going to hit all the negative x values. As it continues out to the right here, it's going to hit all the positive x values. And it looks like this one is starting to now head up, so it's going to hit all the y values in the positive direction. This is starting to head down, so it's going to hit all the y values in the negative direction. So in this case, the domain we say is just x belongs to the real number system. So essentially this says that x can be any real number, and of course the range would be the same sort of thing with y. Y belongs to the real number system. If this graph were somewhat different, kind of continued up this way maybe, so it's sort of a parabola, and this is the low point at -1. The x values, again, as we continue out, will hit all the negative values this way, and we'll hit all the positive x values this way, but the y values basically start at bottom point is -1, and then we want values higher. And so in this case, we'd say that y is greater than or equal to -1. It's still a real number, and so sort of, if we get into kind of fairly proper notation, this is what we're looking at. So it's y belongs to the real number system such that y is greater than or equal to -1. Now, admittedly, I'm not going to worry too much about having perfect set notation, perfect domain notation down here. But that's sort of, when you see it again, you should be able to understand it. Provided you, if I asked you for the range, provided you gave me this, again, should have that there somehow, maybe written this way, just comma, so that I know you're talking about real numbers, you're not talking about integers specifically. That's certainly sufficient. And then end behaviors is probably the one where it may look different. What I'm asking you to do with that is just explain what happens as the graph continues out. Okay, so it says what happens to the y values as we get to extreme x values in either direction. So again, if I'm looking at this, understanding that this graph is now going to continue out this way, what's happening is on this end of the graph, as x, and this is kind of the way we'll note it, as x goes out towards infinity, so as x gets bigger and bigger and bigger, the y value is actually going up and up and up and up, and so it's going to infinity as well. And so this is how we describe the end behavior. As x gets really big, y gets really big. Over here, as x heads out towards negative infinity. So as x gets to be negative 10,000, negative 10 billion, negative 10 trillion, y is getting larger and larger and staying positive, so y approaches positive infinity. And of course, if the graph did do something where it came down this way instead, you'd have x going towards negative infinity, y also approaches negative infinity. And over here, as x approaches positive infinity, down this way, y would be approaching negative infinity. So your actual activity, I think it should be fairly straightforward. So download the file. There are two formats. If you want to use the Word file, you can download it and then just work right inside it. You can type into the various spots here. You still probably need to eventually print it for the sake of drawing in your diagram, but I don't know that this is better, but I'll sort of leave you that option anyways. If you want to use the PDF, then you can just print it right away. Of course, you could print the Word format right away as well. It just depends what you prefer. When we look at it here, I'm going to open it in a new. Essentially, the first part is just going to be a matching activity. And so you're really just kind of looking at the graphs on the right, looking at the equations on the left, and trying to determine what would this equation look like. Now again, this should all be review. That doesn't mean you're going to remember it very well. So we have to sort of figure out what is the 2, what is the 1, how are they represented. Hopefully you can sort of look at that initially and say, okay, well, I do remember that that's a straight line. If there's a square on it, that's a quadratic, a parabola. And so you can kind of narrow it down that way, but then you'll have to determine either by remembering or by figuring it out what the +1 does, what the 2 does, and therefore, is this the right graph? Is this the right graph? And so on. If you don't remember, I've connected to Desmos. I think we've used Desmos already once or twice. And basically, if you need to, you just type it in. Y equals 2x plus 1. Okay, so what does that do? Well, what's that spot? 0, 1. Oh, okay, well, that seems kind of coincidental that there's a 1 here and there's a 1 there. What if it's a negative 1? Oh my goodness, look at that. It's a negative 1 again. And you can kind of, if not remember, then piece together what you need to know about the various parts here. What does that 2 do? And you can kind of play with it and see if you can get a good feel for it. And that's basically it for today. There are other sections to this after the matching. It's kind of write the descriptors of the various parts. What is the domain and range given that equation? What is the degree of that equation? Degree is pretty straightforward. It's the exponent on, I guess I don't think I wrote that, It's the exponent of the largest exponent in the expression. So here, the largest exponent is x has an exponent of 1. Here, x has an exponent of 2. And so we're starting to sort of compile the data, what happens with the domain and range. When I have a second power or second degree exponent, what's the graph look like overall? And the leading coefficient is just the number on, again, the term that has the biggest power. So here it's a 2, here it's a 1, go through and so on, and see if we can kind of get an idea of what's going on in the various graphs. And this is basically just combining the two pieces. Okay, so we've got, based on what we just saw, a little bit of practice, here's an equation. Can you sketch it? Can you list off the information? Given the fact that we just kind of went through and looked at some and we were able to read it off. I think that's basically it. A little bit of a consolidation type question here for linear systems and one for quadratics at the bottom. If you have questions, don't hesitate to ask, and I can answer them now or answer them in a video on Monday to sort of clear up any further problems.